So throughout the course the last couple weeks, we've learned about different analytical tools to help us find out structures of unknown samples. Some of those techniques include mass spec, we've also learned about IR, or infrared spectrometry, and we've learned about NMR, or nuclear magnetic resonance. Okay, so this video is to kind of help you make a structure based off of the information that you find in mass spec, IR, and NMR, and more specifically, guidelines of how to approach and take the information from each. So when we're looking at mass spec, the first thing you want to be able to do is get the molecular formula. That's our main goal from using mass spec. Once we're able to get the molecular formula, we are able to find out the degrees of unsaturation, or the number of pi bonds or rings that are present in the molecule. Okay? So mass spec, find the molecular formula. Once you do that, DOUs, or degrees of unsaturation. Okay? If you've forgotten how to find out the degrees of unsaturation, the DOUs can be calculated by 2 times the carbon, plus 2, plus nitrogens, minus the number of hydrogens, minus the number of halogens, which is denoted by X, all over 2. Okay? So just for reference, X is any halogen. Okay? So do keep in mind, the DOUs don't tell you specifically if you have a ring or a pi bond, but it tells you the summation of both. So if you have a DOU of 2, for example, that could mean you have 1 ring and 1 pi bond. It can mean you have 2 rings, or it can mean you have 2 pi bonds. So just keep in mind, it doesn't tell you the specific type of unsaturation. It's a summation of either a ring or a pi bond, or each individual one. Okay? Once you get DOUs, you move on and start looking at the IR. Number one thing you should get from the infrared spectroscopy graph is going to be functional groups. Okay? And so keep in mind when you're looking at each piece of information, you should be cross-referencing each. So if you have a DOU of 2 and you see nothing in your double bond region, there's most likely going to be a ring in your molecule. You can't be definite until you look at all 3 pieces of information. But look at the IR, and the piece of information you should be getting from that is functional groups. Once you find out which functional groups exist, start looking at NMR. Okay? So NMR is very useful and probably the most specific piece of information you're going to use. And there's 2 types. You have carbon NMR and you have hydrogen NMR. And what both of these are going to tell you, more so in the hydrogen NMR than carbon NMR, is bond connectivity. How are your atoms connected in your molecule? Okay? So because we're looking at bond connectivity, hydrogen NMR ends up being a little bit more useful because the number of bonds you can have to hydrogen are just 1, compared to carbon can have up to 4 bonds. And so since you have less bonds in the hydrogen, or less connectivity in the hydrogen NMR, you're able to find out the specific bonds that exist in your molecule. Okay, so again, to kind of recap, you're going to take a look at mass spec. What you want to be able to find is the molecular formula and the number of DOUs. The DOUs will tell you how many rings or pi bonds exist in your molecule. Once you get that, move on to IR, find out which functional groups you have. And once you're done with IR, move on to NMR, which is going to be the most useful, but finding out the bond connectivity. There are going to be other videos that kind of help explain NMR. It is a very broad subject, and there's a lot to it. So if you're confused on NMR, there is going to be another video on that. But this video is just to show you how to approach structure elucidation by taking each piece of analytical tool and data obtained to draw a final structure.